This video shows how SAKAI carries the test for the element to check its quality. This is the outline what we test and measure for the element. We circulate the oil with the dust using the tank and the element. Then take this oil as a sample to see how much the dust amount contained in the oil. We also see how long the filter lasts on the test. First, we take 500 ml of circulating oil every setting time. Then put the sample taken into another container using the filter paper. We use the filter paper to take the dust data. We use the ethanol to wash away the oil. In this way, we prepare the filter paper only with the dust. Finally, we measure the weight of the dust from each sample, and we determine the amount of the dust and measure the cleanliness. We also measure the time how long the element lasts on the test. When the element is clogged with the dust completely, this is the end of the test. We measure the time by the differential pressure for the oil enter and exit from the element. This test is based on JIS method. JIS stands for Japanese Industrial Standards. This is the dust powder using for the test. It is made of the loamy layer of the Kanto district in Japan, and the ingredients rate is based on JIS regulation. We use 8 grams of this powder to mix in the oil. This is amount of 8 grams. This is 500 ml oil mix with 8 gram powder. It is called slurry. They are the disassembled parts of SAKAI genuine element. The parts number 9032-090020. We test randomly every production lot. The quality of the filter determined by the number of folds on the filter paper, the gluing of the filter material, and the packing quality. Water separation properties and durability are also important point. We check those before the test. This is the testing equipment. The testing method is old-fashioned, but it is reliable and accurate. There are the mixing tank, the pressure gauge, the element to test, and the flow meter. We supply the oil mixing with the dust powder into the element from the tank through the pump. The compounder goes through from the tank to the element and returns from the element into the tank. The slurry is inserted every 5 minutes into the tank, and the compounder circulates from the tank to the element and vice versa. This is the tank where the slurry made by the dust powder and the oil are mixed. The amount of total compounder is 18 liters, flow speed is 2 liters per minute, and the slurry to input every 5 minutes. This is starting of the test. He is now mixing the dust powder and the oil to make slurry, and going to insert the slurry into the tank. We take the sample from the oil returned from the element at 1 minute, and 2 minutes from the test started, then 5 minutes, 10 minutes, and so on. This is the first sample taking. He is taking the sample after 1 minute. We take the sample at 1 minute and 2 minutes in the beginning because it is the time when the dust can be taken the most. They are the first sample taken in the new oil. The left is the sample taken and the right is the new one. You can see the tiny dust particles went through from the color differences. This is the second sample taking. He is now taking the sample after 2 minutes. He is carefully taking the sample from the nozzle connected to the duct from the element. The slurry is added every 5 minutes. As the 500 ml sample is taken, new oil of the same amount is added. They are the second sample taken in the new oil. The second sample seems a bit cleaner than the first one, although the tiny particles went through. This is the third sample taking after 5 minutes. He is carefully taking the sample from the nozzle connected to the duct from the element again. Then add the new oil into the tank. This is the third sample taken after 5 minutes. You can see the dust still contained comparing the color to the new oil. He is putting the slurry into the tank. From now on, the sample is taken every 5 minutes, at 10 minutes, 15 minutes, and 20 minutes, so on. The test will be ended when the pressure loss reaches at more than 90 kPa. We measure the pressure both at the entrance and the exit of the element, and the differences of them become maximum. We end the test. They are the sample taken after 1, 2, 5, 10, 15, 20 minutes from the left to right. The sample from 5 to 20 minutes after are not seen to have a big differences. Next, we measure the cleanliness rate. Dust quantity passed through the element is measured from 6 samples. This is the test equipment. We insert the sample into the equipment first. There is the filter paper placed between 2 containers. The ethanol is added to wash away the oil from the filter paper. We then take out the filter paper and dry it overnight. The total weight minus paper weight is the dust weight. In this way, we measure the dust quantity went through the element. He is now pouring the sample taken into the container little by little. He presses the vacuum button to make the liquid flow into the below container. Then he is preparing the ethanol to add. He uses the same container used for the sample. He stirs the ethanol for there might be invisible dust attached on the container. He then pours it into the container to wash away the oil from the filter paper. Then he takes out the filter paper from the container. Then place the filter paper on the small plate. He pours the ethanol again and leave it for a while. Later he takes the filter paper and dry it overnight in order to take the accurate data as possible. They are the dust from the 1-minute sample and 10-minute sample. The left 2 are the samples of 1 minute, and the right 1 of the 10-minute sample dust taken. We take 2 samples of 1 minute because the dust contains the most in the beginning. Then these taken dust are dried and measure the weight later. We can find the dust amount by deducting filter paper's weight from the total weight. These graphs and the table show the result of the test. The graph 1 is showing the cleanliness, and 2 is the result of element life length. Graph 1 is the cleanliness test result. The red line shows for SAKAI genuine element, and the blue one is for other element. There are the differences after 5 minutes and 10 minutes for the cleanliness. You can see it as data from the table. At 5 minutes, the amount of dust for SAKAI is 61. And the other 128. It means almost twice more dust passed through the other element than SAKAI's. The oil kept cleaner with SAKAI element than using other element. Graph 2 shows the element's life length. After 20 minutes of the test, the pressure loss reached 290 kilopascals and the filter was clogged, so it was the end of the test. From the test, although the element life shows almost the same with SAKAI and other one, the cleanliness shows clear differences between SAKAI's and other one. This is the test equipment for the air cleaner. There is the dust feeder to insert the dust powder, the tested air cleaner, and the filter to measure the dust amount. After putting the dust into the container and run the equipment, we take time and measure the weight of the filter. When this weight is compared to the dust weight inserted, the difference is the amount of the dust the air cleaner took. As same as the fuel element, the dust powder made according to GIS regulation is used. The test is about 3 to 4 hours. This test equipment has a measure to calculate data automatically on the setting time and output the result to the computer. These are the air element clogged with the dust completely. We check the inside as well if the dust goes into inside or not. The air element test is going on. The quality of the air filter determined by the quality of filter paper, number of folds on the paper, how the folds are processed, and the quality of outer materials. For the folds process, we apply the pleats lock method. We check those before the test. They are the result of air cleaner's test. The graph shows the element's life. The red line is SAKAI and blue line is others. As you can see, they had almost the same life length. We also checked the cleanliness rate. This we calculated by the amount deducting dust past element from the total dust inserted divided by the total dust amount. The tiny dust clogged at the element little by little, and so the cleanliness increased little by little, but then the pressure gauge also increased, so the test ended at 120 minutes. At this time the cleanliness rate was 99.90%. It means SAKAI element caught the dust effectively. Both the air cleaner and the fuel element are very important because if the dust gone through, it can give damage to the machine directly. The engine oil element and hydraulic element are important too, but they are the circulating oil to clean the dust. If the engine or any hydraulic component are damaged, it is a huge loss of time and money. Most of machine troubles causes the dust, therefore the element to remove the dust is very important. SAKAI makes and supplies the reliable and high quality of element for the customer.